Welcome to Maths with EJD, and also welcome to Data Analysis with Python. In this video, I'll be talking about time series, rolling averages, and holiday effects. Well, this is basically about working with dates. When you have time series, you're basically talking about working with dates, maybe in years, in month and day, whatever that is. So, working with dates in particular, that's what this video is about, and how those different seasons of the year and all of those things can actually affect what happens in whatever you're looking into, whether it's a business or something like that. Okay. So, of course, as usual, the first thing we want to do is to load the data set. We want to set up and load data. So, here we are going to be needing pandas for data analysis, data manipulation, and all that. We're going to need NumPy for some computation. Then we are going to need matplotlib because there'll be some kind of visualization, though we are not talking about data visualization yet. And then there'll be we are also going to import holidays because we'll be talking about holidays in the US because we're using a data set that is based on flight passengers, airline passengers in the US. Now, I have also brought another twist to uploading data. You can actually upload a data set from a website, from a URL, a universal resource locator. So if you have a particular data set in a particular in a particular uh, website, all right, you can actually upload that. So I'm using this opportunity to introduce you to that. So I've shown you that you can generate your own data sets, by typing things out, like by using Python lists and dictionaries to make and then converting that into a data frame. That's one way. Another way is you can actually get data from external sources. I mean, you can get data sets inbuilt in Python, like the ones we used in the last video, talking about the ones we accessed from Seaborn, for instance, or you can also access from scikit-learn. So you can also do that as data set inbuilt in Python. And number three, you can actually access data from external sources where you can actually have something in CSV, something in JSON, something in Excel that you upload by yourself. So here I'm bringing another twist to it about maybe external sources still. So instead of downloading from that site, you can actually, if you have it on that site in the preferred format, you can actually just reference that and then bring in the data set. So we are bringing in, so you see this data set is from this website, raw.githubusercontent.com. So it's from GitHub by one John Brownlee, and it's data sets master, and it's for airline passengers. So it will be something close to the flights to the flights data set we used in the previous video, but maybe there's a bit of difference. Probably this person would have adjusted the data set a little bit to suit his own purposes. So we are using whatever he has on his page, or whatever he or she has. I don't know who the person is. So on the page, and then so it is CSV by the way. So we can now name the data frame DF, and then we now read CSV from that URL. So this URL is to bring the URL, and this DF is to read that URL to extract the CSV, and then line 10 helps us to visualize. So as usual, let me expand. So we expand now, and then this is what we have right here, like this. Okay, so if I just press Control Enter or Shift Enter, it does works a bit, retrieves from the website, and then this is the data we have, right? We have it's still the 144 rows, except that here we don't have year, month, and passengers. Here we have the month. So under the month, we just have the year and month attached like that. So let's see more by checking the uh, top 50 data points. So okay, so you see that now. So it keeps going like that. Okay, so that is it. So you can see it's like the flight data set that has been modified a little bit, by merging the year and month together in under the month column. Okay, so having done that, let's see. Let's talk about passing dates and set index. So you want to pass dates and set the index afresh, right? So in this case, we are creating so that from the we already have a column called month in that data set we brought. So we have months and passengers. These are the two data sets now because year has been merged with month to give month. So we now pass the data set to just say now there's a date format that is that is useful in Python. So there's a particular date format that you need to put your dates into so that it can be useful in Python. And to do that, you need to do to date time. So that date time helps in Python analysis. So you now pick the month column in that data frame you have uploaded now. So we now you want to modify it such that the dates in that place now becomes you now say to date time is a function inside Pandas. So you now convert that month into that date time because it has year and month. So by the time you make it date time, it means it will now have date again and probably even have time attached to it. And in line three, you're not just so having done this here. So okay, well maybe I should even make that visible. Okay, so let me just end this here and say DF like that. In fact, let me say DF head so we can see the top 50 because that usually gives more a bit more information than when we just see only the top five and the last five. So I do it like that. So let me split this up. Um, just cut this off, and escape B, that's create new cell below. So I just have this here, Control V. So I have df ed 50 also. So for this first one now, when you pass the date, now you're not setting index here now. So this is just for the first one is just to pass the dates. So and then the second one is to set the index. So I've split them into two now. So you can see the transformation as it's happening, right? So this is to set index. So set index. So to pass the dates now, this is what happens. So see, you now have so passing the dates. Do you see what that's done? Previously you just had 1949, 1949-01. That means 1949-01 means January 1949. 1949-02 means February 1949, and so on. But when you pass the date and you put it in date time format, so it's automatic. See, so since you don't give the date, it automatically assumes that that day is actually that the day you're talking about is the first day of the month. That's what this does for you. So you now have 1949-01. So it's like 1st of January 1949, 1st of February 1949. Maybe that's when you give your report. So that's the kind of thing we have here. So, but see now, it's starting from zero to okay, we are seeing 50 to 50, right? So when we now set the index, what happens? Does it make any difference? Okay, so here we are saying month in place, true. So now we don't want to, the index is gone. We don't want the index to be shown. Okay, so you see that's the difference. So the index is gone here. So when you now set index, so it's cut off. So we can just see just the month and the passengers up there. So here too, did we have the passenger hanging? No, it wasn't. So, but here it's sort of hanging up there. So with that done, we can move on to the next thing. So when you pass the date, you are simply saying that the day should be added. And if there's no specific day, it just automatically takes the first day of the month, right? So here now, see what we are doing. We are extracting date components now. So we want to see the year, we want to see the month, we want to see the month number and the month name. So that's what is happening right here. So and the way to do that is say df. So since you have passed the date now, so each date now has year, month, and day, just like 1953, February. First day of February 1953. This is what this is telling you about. So we now want to extract the different components, and the way to do that is data frame under the so you want a new column now called year. So because if anytime you do something like this, since there was no year column up there in the data set before, you now want to add a new column called year, and the way to get it is you now df.index year. So in the past date, it automatically recognizes the first thing as your year, and it recognizes the month number. All right, it recognizes the month number as the second thing, and it automatically matches that number to the name. So and you use df-index.month here, and then you use df-index.month name like that, and that's but with the number you get that. So with df, we now visualize that. So you see what we have. So now we have month, passengers, the year now. So you have extracted the year out, the month number 01, you've extracted the month number 2, and then January, February, March automatically we'll go with that. So let me do the top 50 that I've always done to get as much information as we can get from the setup. So see that here right now. Okay. So we have all that. So it goes to January again and it starts from the beginning. Each time it gets to 12 and it just keeps going like that. That's what we have done. So you can actually, so in case you want to do just something with the month and year alone, from a past dates. You can extract year by just using the data frame, whatever you call it, whether it is data you call it, or Titanic you call it, or flights you call it, dot index dot year, whatever the data frame is named, you use that like that. So the next thing we want to do is to want to look at average passengers by month. Average passengers by month. So just like what we saw in the previous video where we're talking about grouping and aggregating and everything. So we want to get the monthly average of passengers, right? So want to look at it like, we have the data set from 1949 to 1960. So we want to say that for all the Januaries, for the how many years is that? 1949 to 1960. That's like 12 years. If you include the 1960 minus 1949 is okay, 1950. So that's like 12 years, right? That's like 12 years. Because 1960 minus 49 is 11 plus 1949 itself, that's 12. So if you want to say all the 12 Januaries, all the 12 Februaries, all the 12 Decembers like that, were the average value, average passengers? So that can give you an idea that, oh, for Januaries, this what as an airline that can help you to get ready for the kind of passengers we're going to be having for those months, having studied that for 12 years or so. So we group by month name and we take the passengers, the mean of them, and we sort values in ascending. So that's from the biggest to the smallest, right? Ascending from the smallest to the biggest, that is. So now I go for the monthly average. So that tells us average passengers by month. So easy. So it tells us that, in July, you have three average of 351 passengers. So you can, you see that July and August, the behavior is about the same. And since it's in ascending order, so that means that ascending, it's going up, right? So you see from November. So ascending falls, that means it's descending. So it means the highest number of passengers is in July, and August is about the same. And for obvious reason, July and August are summer months, and it's very close to June also because June is also the beginning of summer in most cases, right? So you see, most of the flights happen in summer. So summer is busy time, so you want to get ready seriously for that. And then you go to September, it's 302. Then you have May and all. So the least time is when you have 232, and of course, that's approaching winter already. In winter, you have 261, so like that. But winter is at the peak around January and February in most places, right? So that's why the smallest is in November. That's like everywhere is already coming and people have finished their travels and things are settling. So you can already draw that insight from this place. So if we say ascending is true, for instance, it means that it will start from the smallest to the biggest, so it has reversed this thing. So it all depends on how you want it. Okay. So we can also sort and filter sorting and filtering by dates is possible. So here now, imagine you are creating a new data frame. So you say data frame underscore 1955 onward. So starting from 1955 till 1960, that's what we are doing now. So here you just say df dot index greater than or equal to 1955. So you are using the date now to do that because we surely have 1955 somewhere. Okay, if you continue this now, say if you go on with the next uh say what if I do this, say from 50 onwards? If I do this, I don't know if I think that should work. Oh, it's not working. Can I say 50 to 100? Is that possible? I think that should be. Okay, that's not working. There should be something. Let me see if I put it in a box, if that works. In this. Oh, it's still not working. There must be a way to retrieve all that. Mm, Okay, I can do till now. I can do till the last 50 because everything is 144. So I can do till of the last 50. So I want to see that 55 showing, right? So I have TARL and do this. Good. So 1955. Oh, okay. This doesn't uh have that. Um, okay. 1955 is not part of that. Okay, let me see the till 60. Let me see till 60. Okay, still not showing. What about tail 70? Yes. But that 1955 is what we are interested in. So let's do on okay, let's do tail like 80 because once yeah, 1955 can show now. Okay, it is missing in between somewhere. Let me see. What if I do 75? Yes, now we have 1955 0101. So what is happening down there, like we're going to see, is we want to do everything starting from 1955 onwards. We just want to see everything that have been happening from 1955 January 1st till 1960. So here now we are doing compare pre-1955 versus post-1955. So here we say before. So we say df dot index less than 1955, and this one is greater than or equal to 1955. So this is before and after, and we take the average number of passengers like that, and then we can print those values to see the number of passengers before and after 1950. So before 1950, we had average passengers of 182, right? And after 1955, it's increased to 377. So it means that 377.69. So it means more people have been embracing uh, flying, right? Because flying was just beginning to gain ground then. Okay. Then we also talk about resampling and rolling averages. Now, when you have a data set, you can resample according to days, according to months, according to weeks, and everything. It's very so you can do that kind of resampling. So sometimes, when you are working with especially a sparse data set, daily data set, for instance, and some days are missing, so you can actually resample it to week or month or year, so that you have the data is more robust, although you'd have probably missed out. So you may not have to go all the way. You can just go like from day to like week or month, and then you can work with that. So the data we have here, for instance, is a monthly data. So we can resample it to year. Okay, so and how do you resample? So for yearly resampling, now since you have a monthly data, so you can say data frame yearly equals data frame passengers, and you resample to YE, and then you sum that up. All right, so you sum up whatever you have for all the months and into 1 year, right? And then you have DF yearly, and then you plot yearly passengers total, and this is the kind of thing you're going to have. So we have a plot in that situation. So what if I really want to visualize that yearly, right? So we have 11 years, so I can just do it straight. So it shows everything at once. So see what happens. So what it does is that in the whole of 1949, it sums up all the fly all the people that flew in 1949 from January to December, and it reports the total passengers for 1949 by December 31st, 1949, and does the same for 1950. So instead of having it monthly, so it sums up. So you can do sum, right? You could also do average. So imagine this is yearly resampling for some now. So you want to sum up all the people that flew for that month. So what if I want the reports to be those who flew in a particular year, the average. So I'll just come here instead of sum, I just say mean. Okay. So for mean now, see what happens. So it means an average of 126 flew per month for those for that year. I mean, so in 1949, right? So if you do the average per year, I mean per month, this is the kind of thing you get. And you see the graph also it looks almost similar, except that here this is the total and here this is the average. So you can do things like that. So it's more like dividing 1520 by 12. That's why we have that, right? Okay, so you can resample data like that. So you can resample a weekly data into monthly or yearly and all of that. So now let's talk about rolling average. Now rolling average is like you are summing. So like if you say three months rolling average, it's like uh from the data set you had initially, right? You had the first 3 months. You add the passengers for the first 3 months. You divide by three, so that gives you the first rolling average. Then you move to the next three, the next like that. So that's the idea of rolling average. Okay, that's the idea of rolling average. So for this now, once you do 12-month rolling average, so we'll sum up all the values for a whole year because that's 12 months in 1 year, and you get the mean like that. I think that's what I've even it's close to what I already did up here, but let's see how that works here. Okay, I think that's like what I've just done with this next example right here. Okay, so we are creating a new column called 12 months average, and then we are taking the passengers column and we are doing the rolling, and the window is 12, so we can make it quarterly by taking 3 months, and we want to find the mean for those 12 months, and then we have so we now have from that data frame now we now have DF passengers. So I mean for us to appreciate uh what's happening, we may have to we may split this into two so you can see what's happening. But I'll do the overall thing first. So I run this, and this is what we get. Okay, this is what we get. I think that's pretty close to what happened up there. Yeah. So, but then if you want to appreciate this a bit more, it's better to visualize each data frame separately. So, okay. Okay, yeah, the plot is in the next line. Okay. So I cut this off and then I have df dot head and I say 50. Do we even need 50? Because we are doing 12-month average already. So I can just say df alone, right? Df alone should just work. So we have this. So it's okay, I think 50 will be necessary here. So you see the rolling average head and 50. So we have this. So you see, what is happening here is that this value you're going to get is you add up all these first 12 and divide by 12 and you get this. Then the next set of two. So you now start from the next one again, add the next 12 and you get this result. And it goes on like that. That's the idea. So that's why all these averages, all this January to November are no longer existing. So add the 12, get the answers for this 12. Then move to February, add from February to January next year and you get the answer. Then move to March, add from March, so count 12 months, and you get to the next February and you get the result. So that's the moving average. Okay. So if I show the next part, if I show the next part, so let me create a cell down there. So I have this now. So you can now appreciate what's happening right there. So this is just the plot to show. So this is the plot for the moving average. So you see that it doesn't start from the beginning of 1949, like what we saw previously. I think we had a plot like that, that started from the beginning. Maybe not yet. Okay, not yet. Okay, I guess this is the first plot. Okay. So you see the 12-month moving average is moving like that, and that is where this is coming in now. So plot monthly passengers and 12 months moving average. So the Y label is the passengers, all right, and you have the months right here. So like 12 months going from year to year. All right, so let's talk about time differences and growth. Time differences and growth. For instance, you want to see monthly change. In that case, you use the diff command, this diff now. So you have time difference and growth. So let's look at the monthly change. I run this. Uh, okay. So for the monthly change now, so you see now that between the first month and the second month now, okay, there are six passengers difference. 180 minus 12, you have six. 132 minus 18, you have 14. Then 129 minus 132, that's negative. So the number of people that flew between the 2 months has dropped. That's the idea of monthly change right there. So you can do that. So you want to find the difference between corresponding months. That's what monthly change is all about. Okay, so we can also have percentage change. So the percentage change, like for instance, now you have the change between 1 month and the other is six. Between January and February 1949 is six. So it means you have 6/112 divided by 100, 6/112 times 100, and then you get the percentage change. That's what you have right there. It's like 5%. Okay. Then that's percentage change. You may also want to get year-on-year growth. Year-on-year growth. So year-on-year growth. So for year-on-year growth, you do percentage change for 12 years. I mean, for 12 months, right? So for year-on-year growth, so the percentage change will now have an argument called periods equals 12 multiplied by 100. So if you do this, you get the year-on-year change. Okay. So um so the year-on-year change, you have all this one. So this is not showing because it's so you do for 12 months. So the first year-on-year change comes at the beginning. Let me see. It's better to have 50 so you can see as clear an information as you may need. You can use that is okay. So see the year-on-year change now. Oh, I did head. Let me do 50, right? 50, right? Okay. So you see the first year-on-year change comes by uh December of the first of the but in fact by January of the next year because so this is the year-on-year change now. So you have the year-on-year change after 12 months. What is the change like number of passengers? So it's more like some averaging you've done over the time. Okay. So we can talk about the peak growth. Peak growth. So for the peak growth, now we want to see the maximum growth that has happened over the whole time, right? So you have maximum underscore inc underscore date. That is for the monthly change now. Yeah, you want to get the maximum. So you now print F max the increase. So the increase in monthly changes in passengers. So you see that from 1960. So by the end of 1960 of the data you're using, so you have had an average growth of 87 passengers in all, right, over the course of time. Talking about the monthly changes. Okay, so having dealt with all that, I mean, that next section was about that 8.4 was about time differences and growth. So now let's talk about holiday effects. What effect do holidays have on your business? In this case, it's an airline business. All right. So in your own business, you may notice that maybe there are peak periods or something. Maybe yours is not holiday effect. It may just be some other thing based on your particular context. Maybe you sell on the university campus and when students resume afresh, they have a lot of money to spend, and maybe that's the peak time. And towards the exam times, the money is they don't the money is all gone, and then by holiday time, there's little or no business because you have just few people coming to school. So you may have something like maybe some vacation effect or something like that in your own situation. Interestingly, in Python, there's a just like we uploaded before, we imported holidays because it's actually a Python library for dealing with US holidays, right? So we have US holidays, underscore holiday, that's the data frame. But holidays is a library where you now have US as where you have US as a function. So, and you want to find all the US holidays within the range of 1949 to 1961 because we want to get to 1960, so we have to add one to it because it won't get to the last one. So, because you want to access 1960, so you go a step higher. So you now say DF is holiday. So DF index to series, then apply lambda X in US holidays. So what we are simply trying to do here is to any date that is a US holiday, we are already, any day that is a US holiday, it is going to return true. So if there's an holiday, it tells you it's true. So look at this now. So of course, January 1st is public holiday because it's New Year Day, you know. Then we can go on like that. That's true so far. Then okay, another true here because it's January every January 1st is holiday, right? Is there any other true we found? Okay, that's the only true so far. Would that be the only holiday? Okay. So January 1st is still the only one so far. But I'm sure that shouldn't be the only one. Uh January 1st. Is there any other one? Yeah, there's September 1st. Good. There's September 1st also. Let me check all that. Yeah, okay, 1951. Maybe the holiday hadn't started in 1951. I'm not sure. So let's now talk about holiday names now. Holiday names. So those same holidays you've seen up there now, we want to see their names, right? So I run this now. So we just say holiday name, and we just want to get for X in this, and it gives us the name get X. So we have New Year's Day, just like we saw already. New Year's Day, and then I think probably Labor Day started in 1952 because we don't have Labor Day in 1951. Interestingly. So maybe it started then, I'm not sure. So that is something that should get you curious. That when did Labor Day start in the US? We can even Google that. Uh, when when did so your curiosity should be on as you're working with data. When did Labor Day start in the US? Because it's looking like it didn't start in 19. Okay, organized labor 1959 to 1950. The labor history. History of Labor Day. The first Labor Day was celebrated on Tuesday, September 1882. Okay, so there must be something wrong with this data. Maybe something somewhere is not right. That's why September 1st, other years is not showing until 1952 that we saw right there. Okay, so I mean, those are the things that should get us curious to find out what's happening. So then we can talk about the holiday months. So we already know it's January and December. So is January a holiday month? True. So every January is a holiday month, as well as September. Although the first one is not showing, but later we have some other September showing holiday, starting from 1952. So September is now showing as holiday month. Then we want to find during holidays, what is the average number of passengers? All right. So here we just say holiday average is equal to DF. So the holiday month under the data frame now, and you take that again. You want to compare, is it equal to this holiday month is equal to one, right? And the DF passengers mean. So we want to find all the holiday months, right? So you have 251.0. Then what about non-holiday passenger average? That's 283. So it means that uh it looks like there's interestingly there are still more flights during non-holidays than holidays because holiday months are just few, right? Based on what we have here. Okay, then we have holiday effect visualization. Take note, we have not factored in things like summer and all that. It's just holiday, like public holidays, so to speak. Then now visualize holiday effect. So here now we have the data frame of passengers. We are plotting that, and then we have holiday month. That's one we just saw up there now, like that. Then title of the. So if you run this now, see what we have. So the holiday, so these are you have holiday months for this now because it's some kind of moving average because we did it for like so we are focusing on the months, right? So we have that January and September also happening in places like that. Or for now it's just only January. That's New Year's Day. So I guess this data I mean just make sure you're using the right kind of data, then you'll be fine with whatever you get. Now let's look at event-based tagging. Event-based tagging. So now you want to create a new column called event. So you see this is where you now use NumPy. NumPy where so you are using a where kind of statement now where df index month is equal to 12, you have Christmas. Then NP where df index month I signed 7,8 is summer. That's like you have months July and August, and you call say that to be summer, and then we can visualize this. So it tags the necessary years as summer and winter, right? So we have so summer is for so you see summer is in July and this July here and August, that's summer. And then we have Christmas in December and it goes on like that again. So July, August is summer, and then we have December as Christmas. So those are events now. So you can make that work in your data. Then we can now compare event means. So how do the flights look like during summer and during Christmas? How do they compare? Okay. So you have the new data, the new name for your data frame, which is event underscore means, and that is equal to df dot group. So you group by the event, whether Christmas or summer, and then you find the average number of passengers across these two. So if you run this now, you see Christmas has 261.83 and summer has 351. And if you're talking about the context is the US, by the way. So of course, Christmas is winter and summer is warm weather, so people can move around freely. So it's justifiable that you have more people flying in summer than in Christmas. So if it is the other way around, you want to drill down to see what exactly the issue is. Probably, whatever. I mean, it may just be a pandemic here or something, and maybe some black swan event, some rare events occur, and then you now have something that is what's the word now? It's anti counterintuitive. Yeah, it's counterintuitive. So sometimes you find counterintuitive things in your data, so that will help you drill down to find out what exactly happened that time for that kind of situation to be there. So then we talk about seasonality overview. So you want to see for the seasons, what's causing the differences, why are there differences and things like that. So uh seasonality now. So you want to group by the month, and then you want to find the average passengers for each month. Then you want to do a seasonality plot using bars to show average passengers by calendar month and all that. So you have your X label, Y label. When we get to data visualization, you'll understand more of this X label, Y label thing. So I do this and then it just shows us this. So you see that the peak periods are July and August, right? July and August are the peaks, and the lowest times will be, I think it's something around February and November. So November is like, the fall is setting in. So summer is gone, everything is getting cold again. And then cold, uh, you know, like that. And then it gets cold gets to the peak around February, and by March, things are picking up again. So you can see, you can draw a lot of insight working with time series data. Um, in the future, definitely, I'm going to talk about some. By the time I get to data science and we're talking machine learning and things like that, I'll be working with some time series data and use some other very advanced techniques like ARIMA, Prophet, and all of that. All right, so let me know how helpful these videos are for you. Let me know in the comment section. Let me also know if there's a topic you like me to teach or a problem you like me to solve, or you have a data set you like me to work with, which you want to send to me, or you just want to give me an idea, then I can make up the data and work with it. I'll be doing a couple of projects after I take care of the main parts. So then I take a data set and run through it, draw insights, make recommendations and things like that. So if you have something in that line that you'd like me to do, just let me know. And don't forget all the data sets I'm using. I mean, this one, the one I used for today is from a website. So all you just need to do is run that URL and do the first thing I did to get that data set. Then the one I used in the last video, they are inbuilt in Python, accessed through Seaborn. So as far as you call Seaborn, you can get that data set. Then, but the external ones, like the ones in CSV, Excel, and all that, you can get by checking the description box either on Facebook or YouTube, and you can click on this and you get all the documents I'm using and all my, even this code sheet. So in fact, I always advise that you download those things first, and follow along, because the best way to code is to actually code. If you have subscribed to this channel, thank you. If you have not, you know you're missing a lot already. So you want to subscribe right now, hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content. Until I come your way again, keep doing maths right, keep doing data right. See you. Bye.